and I promise that you are going to enjoy this session as well. So today's session is going to be a really important one. We are going to talk about factory and registry patterns in Solidity. Uh, I know the names sound fancy, uh, but you will see them everywhere. Like Uniswap uses factory, ENS, Ethereum name service uses registry. So they are very known in the Web3 space for some time in Solidity. So you are going to see these patterns everywhere in protocols or any infra level DeFi protocol. So this session will be about 2 hours. We'll spend roughly half an hour on the doubts and 1.5 hour on explaining the session. We will have a 10 minutes break in between to address your doubts, so you can ask your doubts in that time. So, and if you get any doubt in between, you can just drop your doubt in chat, or you can unmute and ask your doubt. Okay, so let's start. So before we start, let me tell you what you will walk away with today. Majorly 4 things. Number one, you will be able to clearly explain what a factory pattern is and what a registry pattern is, and most importantly, how they are different from each other. A lot of people confuse between these two, and when to use which pattern is like a big confusion when you start building. So I'm making I'll make sure that you'll understand that. And number two, you'll know when to use which pattern, because knowing what something is and knowing when to actually use it, they are very different things. And number three is you will be able to read and implement basic factory and registry smart contracts after the session. Fourth one, you'll understand the practical considerations, the gas cost of deploying using factory, and gas cost for using a registry, what is created to proxies, clones, access control, and security. So let's let's before knowing what factories and registries are, let's first understand uh, why do we need factories and registries. So we will start with factory. Factory helps in production with systematic rules and guidelines. So suppose you go to a Tata showroom, uh, you get a Tata car built to Tata specs, Tata standards, Tata's quality. You can't walk in and say that I need a BMW. The factory decides the blueprint. You just choose your configuration. You can choose the color, you can choose the model. Same thing on chain. You can just pass the arguments in the constructor, and suppose you want to create a vault, you just need to specify that you are the owner. You cannot specify how this vault will work. The vault depends on the blueprint that is being created by the protocol. So it helps in production in with systematic rules and guidelines. Uh, Also, standardization builds trust and verifiability. So if you know that this car has been created by Tata, so you'll trust them. And a similar car with same specs is being created elsewhere, you won't trust them because that is not been created from that factory. So that also gives it a label, and that that gives you trust and verifiability that that is being created with total honesty and the correct blueprint. Now, why do we need registries? Registries help in discovery, identity, governance, and proof. Imagine a city with no addresses. or no Google Maps or no signboards. It will be a total chaos. Like if you want to go somewhere in the city, you need to remember everything that I need to take left from there and then right, then left, then again right. So you can't remember all that. You need to have a registry. Like if you want to go to that address, you have Google Map. You can just turn it on and you can see, you will go there. So registries are very important. Uh, let's take another example. Uh, like Aadhaar card in India is, I think, very good example of a registry. The government uses it to enforce rules, distribute benefits, and verify your identity. You prove you are a citizen by showing your Aadhaar card. Same on chain, a registry proves this contract is legitimate, it's registered, it belongs to this owner without anyone can claim anything. So it helps in discoverability and easy query. You can easily query something like, how do you know that this pool is being created by Uniswap or not? So they have their own factory and they deploy it using their factory. So, and they treat their factory as a registry as well. So you know that the pool is associated with Uniswap. Uh, Now let's discuss about what is a factory, a very basic question. So a smart contract whose primary job is to deploy other smart contracts. That's the very basic definition of what is a factory. Uh, think about it like a real world car factory where you walk in, you give them specifications. I want this model, this color, this features, and they manufacture it for you. Different specs, different products, but the assembly line, the machinery, the process, all the same. So you can consider that as the blueprint or the bytecode of the contract when you consider it on chain. Uh, these are few characteristics of a factory. Uh, the main job of the factory is to deploy child contracts. There are few patterns you can use to deploy contracts in the factory. The first and very basic one is new. You can use the new keyword given in the solidity. So you can directly use that to deploy uh, a child contract without considering anything. Just you want to deploy a simple contract using another contract. That's a factory. You can use create to keyword as well. We will discuss all this in details. Or clones. Second characteristics is it often stores deployed address internally. So the factories, like when they deploy the contract, they store that this is being deployed by this factory. So the factories they work as registers as well. So whenever they deploy something, they store it. Uh, Third characteristics is standardizes deployment. You cannot have the different bytecodes for uh, you cannot like deploy different contracts using a same factory. So the factory standardizes that. So suppose you want to create a garden that we have in BLOK Capital, you need to use the same contract, same bytecode to deploy that. You can just you know tweak the parameters as per your need. That also that are also being like checked by the factory. So you can pass, you are the owner, you can pass which uh, collection you want, you can pass, do you want to create a index garden or yield garden. You can pass few parameters into that, and that is what will differentiate your child contract with other child contract, or your vault with other vault. Uh, Core characteristics, it allows you to give single entry point for creating instances. So you want everyone to create vault using the your protocol or your interface. So, or a single entry point you want, because you want to store that this are the vaults being created in our protocol to track, to better track the records or vaults. I hope I'm clear. If anyone have any doubt, they can drop in the chat. Okay, no doubts. So again, now let's look into registry. What is a registry? A registry is a smart contract that maps identifiers to addresses or metadata without necessarily deploying anything. This is the main point on the statement. The registries usually don't deploy anything. They just registers the addresses or components or anything you want to register in the registry. Uh, their job, their deploying anything is not their job. So this is important to consider the registries. This is the main point why they differ from factories is that they they don't need they don't deploy anything. They just register. Let's discuss the characteristics of a registry. So the first is it stores mappings. Could be name to address or ID to structs, could be bytes 32 to address, whatever identifier makes sense to your project or your protocol. You can choose the mapping based on that. So it can be of any type. Second is it does not deploy contracts. That's obvious. That this is not job of registry. Uh, it doesn't need to deploy any contract. Third is it acts as a discovery layer. It's the source of truth. Other contracts can use to query uh, or look up. It's like it acts as a directory for anything you are storing or anything you are registering. Fourth characteristics, it often has access control, like who can register, who can re-register, or because it will be total chaos if you don't put access control in the registry. If anyone can come and register their own data, then they'll spam it. So these are the four main characteristics of the registry. So to summarize it in one line, factories create things, whereas registry catalogs them. Okay, so now let's put them side by side. We'll compare the registries and factories. So primary role. Obviously, the primary role of a factory is to deploy to deploy new smart contracts, whereas the primary job of registry is to store the existing data or anything that if you want a registry of the deployed contracts, so it is already deployed. So it's the already existing data you want to store. It's the primary job of registry. Uh, Creates contracts. Obviously, yes, factory creates new contracts using new or create to or clone, whereas registry don't create any contract, it just records it. Stores data, yes, it stores the data. Factory deploys the contracts and then stores them in the storage. Registry, yes, it's the main purpose of registry to store the data. Uh, Fourth one is access control. Uh, Factories usually require no access control because they act like a vending machine or something like that. You can just they are public. You just you just call that to create your like suppose you are creating a vault or you are creating a garden. You you can't enforce any access control into that. It should be public, otherwise will be how people will be able to create their vault or their gardens. So most of the factories, they don't need any type of access control. They just make it the public. Uh, in some cases, you can add access control into the factories, not on the create functions, but on the other functions. If you want to set some variables or something, so you can use access control, but they doesn't require any access control. Whereas registries, they heavily depend on access control. Like it should be either owned by the DAO. If if it is a protocol, it should be owned by DAO or multi-sig wallets to make sure that no one can come and overwrite the storage that is already being stored, or anyone can come and store anything. So protocols doesn't work like that. They require a total access control, and it should be DAO governed. Gas cost. Uh, Factory requires high gas cost because of deployment cost. When you deploy the smart contract, uh, when you deploy the smart contract, you deploy the entire bytecode. You take the entire bytecode in the factory and put it in on blockchain. So it requires a huge amount of gas fees, whereas registry doesn't require uh, much gas fees because it's just storage right only. It basic function to just change the storage. So gas cost on registries are very low compared to factories. I hope I'm clear. Any doubts? Okay. Now we have basic idea of what a factory is, what a registry is, why do we need factories, why do we need registries.
We have
So
one
now,
question,
yeah,
Jack, in chat.
yeah, I'm looking. Yeah, I'm looking. Does it mean that registers to declare clone of factories? Deploy clone of not the clone of factories. The factories deploy the contracts, and the factory stores that contracts. The clone which we are talking here, we'll discuss that in detail later. You will understand better. But usually, the factories are registries in themselves. They themselves register what they are deploying. Registers don't like registers can be independent also. Okay. All right. Now we discuss basic stuff, and now it's time to deep dive into factories. Uh, we are going to cover three types of factories. Simple factory using the new keyword. This is the most basic one. The starting point, you can consider it as the hello world of factories. The second one is create to, for when you need to deploy uh, deterministically predictive or at predictable addresses. before the contract is even deployed. We'll discuss about this, like why do we need to deploy contracts on predictable addresses, or why do we need to deploy contracts deterministically. So yeah, the third one is EIP 1167 clone. Uh, or when you need to deploy hundreds or thousands of contracts, and cash cost is your priority. Deployment cash cost is the priority. At that time, we use EIP 1167 clone. Let's start with the simple one first. Simple factory. Just you create a factory contract and we deploy this directly with child contract, child equal to new child contract, and just pass the arguments arg1, arg2. If you have used Foundry, so you must have deployed in the script using this syntax, or this the most basic syntax we deploy uh, contracts through. Under the hood, how things work is like whenever this thing is called, step one is EVM runs the create opcode. It's the low level opcode which Ethereum virtual machine runs in the background to deploy this contract. Second step is it takes the full bytecode of child contract, every single byte of compiled code, and deploys it to a random new address. That's why it is expensive. You are paying gas for every byte of code you are putting on chain. So that's why factories are little expensive than the registry. Third step is like it deploys that contract to a random address on chain using the nonce value, and then it returns the address or where did it deploy your code to. Okay, so now let's look at the code example of simple factory. On the bottom right, you can see the simple vault. This is the child contract. On top left, you can see the vault factory. So first we'll start going through the simple vault on the child contract. It has two storage variables, owner and name. They store who's the owner of this vault and what is the name of this vault. So whenever this simple vault is deployed, the constructor we pass address, owner. We have a doubt similar to creating class object. Yeah, it's similar to creating class objects instances in other languages like JavaScript or Java. It's the same thing, actually. Yeah. So in the constructor, we are passing owner and name whenever we are deploying the vault and storing that in the variables, so the global variables, owner and name. We have received receive the ETH into your vault. So this is exclusively for receiving ETH into your contract. And then we have a function, basic function to withdraw and it has a require statement, message.sender equal to owner. So it checks that if the caller is the owner of this vault or not. If it is not the owner, it will probably revert. And then this calls the contract to withdraw the amount that user want. Then we check if the transaction is success or not. So when the dot call is low level call. If you don't check the success, sometimes it fails silently. You will not know that the withdrawal has failed, but it will show you the success. So you need to check that if it is true or not. It will not revert. It will just pass. It will not throw any error. So to throw error if it is unsuccessful, you need to check this. Just you can keep this in mind whenever you create a withdraw function. Now in the top left we have vault factory, which has an array of vaults. It stores the vault addresses. It has an event vault created, and it indexes the address vault, and it indexes the owner. I have a question. So before drawing you, like what I was saying before is that the factory deploys the campaign and the register moves the list of declared contract wherein the mention they can be independent of each other. Yeah, like factories and registries can be independent of each other. Uh, Usually, the factories that we have in production all over the Web3, like in the DeFi space, all the protocols, the factories are registries in themselves. So whenever they deploy something, they store them immediately in the atomic transaction. So like you can take the example of Uniswap V3 factory. So whenever they deploy any pool contract, ETH USDC or like WETH USDC or WETH WBTC, they store uh, in the same transaction. When they deploy the pool, they store it in the storage of that factory. So basically, the factories are registries as well. But the registries that are created independently, they, their main purpose is to store uh, something heterogeneous that is like suppose factories deploy the contract of the same type, so they store the contracts of same. Why do we need registries? Like when we try to register some heterogeneous content or storage. Yeah, thanks. Yeah, so let's discuss about the vault factory. It is a address array of vaults, and as the event vault created. So whenever you create a vault, it emits this event. It indexes the vault address as well as the owner of the vault. Uh, it is a function create vault where you pass the string, the name, what you want to name this vault as, and it returns the address. It deploys the vault for you, and it just returns this create vault. Just returns the address of the created vault. This particular function is like this function is heart of the factory. It is what it makes a factory a factory. So the first line in this function, the first syntax is simple vault equal to new simple vault, and you are passing the construct arguments message.sender and the name. Now you can see that why factories are important. Like if we didn't had this factory, instead of message.sender, anyone could have passed any malicious address here, and or by mistake the user himself would have passed a wrong address here. So that can lead to ownership of your vault can be taken by someone else. Suppose you are trying to create vault using the front end, then this message.sender will not be you. Like it will be if you are directly creating the simple vault. So you can pass any parameter here, any address here. So the create vault, it forces you to pass message.sender as the constructor argument, and the name as it is. The second line, vaults.push address vault. So you can see that although it is a factory, but it behaves like a registry as well. So whenever you create a vault, it stores that address into the array. If this would have been any advanced factory, they would have a different type of storage, a mapping, and different type of mappings, more constructor arguments, more storage. So this could have been a proper register in itself. But the main purpose of this is a factory, and this can behave like a registry. There's no doubt in that. But registries cannot behave like factories. So that is very important. And then it emits the event vault created. Make sure every time you do anything on chain, uh, you emit event. Please keep this in mind. Whichever function you are creating, if you are altering any storage, if you are deploying anything on chain using any function, so try to emit event every time whenever you are withdrawing something, when you are depositing something. So try to emit events every time you do any write function on chain. It helps in indexing, and like it helps in subgraphs, and it helps block scanners as well to track what happened with this contract over a certain period of time. So it becomes easier for off-chain components to track your contracts. Otherwise, it will be completely unknown contract sitting on the blockchain. No one would know about this if you don't emit any event. The second function is to get volt count. So it returns the number of volts that is being created till now. I hope everyone understood what simple factories. If anyone have any doubt, they can put in the chat. Okay, no doubt. So either I am explaining too good or too bad. Okay. Okay. Thanks, Vijay. Thanks, Vasim. Thanks, Ankit. These are all my friends. Thanks, Abhi. Thanks, everyone. Okay, so let's now jump to create two deterministic addresses. So very important point. Why do we need deterministic addresses? Like, why do I need to deploy something on a deterministic address? The very first thing, why would you like to deploy any contract on deterministic address is like if you want to deploy the contract multi-chain, how easy would it be like if you can deploy the same contract on all other chains at the same address? And how difficult it would be if you deploy this contract on all the chains using new keyword and you don't know the address because it uses nonce value. Each time when you deploy on all the chains, it will be different. So how hard would it be to track the addresses on all the chains? So this is the first thing that why we use uh, create two or deterministic addresses. The second point is like, what if you want to like, send some funds to the contract before even deploying it? And at the time of deployment, you need that funds to be in the contract. So for that reason also you can first calculate the address where you are going to deploy the contract. You can send some funds there, and whenever you are creating the contract, you can just use that funds to perform certain things, or like this is very cool to like send have the funds on the contract without even deploying it, before even deploying it. So also there are some use cases we are going to discuss later. uh, yeah, Wasim, you can send like funds to address before it's like before the contract has been deployed to that address. It is practically possible. You send the funds first, then not using self-destruct. Uh, like all the addresses on blockchain exist from day one. You just don't know them, or there's no data there. But when you send to, for example, some address or data, like yeah, 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 they just wait to be like kind of activated. They exist beforehand, even before, like your wallet address was there since the beginning. When you created your wallet, you just got the private key for that. Quick question: shouldn't the contract address be same every time? This way, it is technically uh not the like only hash of bytecode, but it has different parameters in deriving the address of the contract when using structures. Yeah, like it depends on the many parameters. Like it depends the contact, the address that where we are going to be deploying. It, dep- it is calculated using different type of parameters, like who's the deployer of that contract, what is the salt passed to that contract, what is the bytecode of that contract. So all constructor arguments, all these are taken into consideration before you deploy. That address is calculated using this formula. Basically, control the address outcome of contracts can use this feature as suits us. Yeah, address is an Ethereum address you can calculate and use meaningfully today for a contract that might only exist tomorrow or never. Thanks, Mr. Dipender. Nice. I think Sheetal sir gave a good explanation there. You can refer to it. Okay. So uh, there is only slight difference between the syntax of create to and normal simple deployment. All Everything is same, just the salt is being passed in the curly braces. That makes the difference. This is what internally triggers create to instead of create. So when without passing the salt, when you deploy the contract, it the EVM internally chooses create to deploy your contract, and that create uses nonce to calculate the value of the contract address where you are going to deploy the contract. Whereas this when you pass the sorry question, this feature can cause DOS. How can this cause DOS? if you think like anyone can predict the address of the address we are going to deploy before us, there are few considerations that there are few security measures that you can take to deploy that contract. Uh, at the you, you need to vary the salt you are using to deploy this. Like passing message dot send using message dot sender in the using message dot sender in the salt is what makes the difference. If you are using message dot sender in the salt, no one can front run you. Nonce is not used in create to, because if nonce is used in create to, the nonce will be different at different times on all the chains. So once you deploy any contract on a chain, if you try to deploy the address, if you try to deploy the same contract on another chain, you will not be able to deploy on the same address because of nonce value. So nonce value is only used in create. It is not used in create to. They cannot block the deployment. They can front run your deployment. Like before you go and deploy your address, they can front run you, and before even you try to deploy, they'll go and deploy. But if you pass message.sender in as a salt, uh, they probably cannot do that. Yeah, message.sender makes the difference. Yeah. Init code cannot yeah, if message.sender is passed as a constructor argument, then your init code is going to consider message.sender. So yeah, true. Okay, let's continue. Create to formula. So there is a formula to create, determine the address before even deploying it. Like it uses the catch it to 56 algorithm to calculate the address. It combines these four things: 0x double f, bytes one constant used in the algorithm of create to calculate the address, plus the deployer address who is deploying the contract, plus salt, and plus can check 256 of byte code of the contract you are going to deploy. So it hashes all of that, and then it truncates that to 20 bytes to make it as a address. So in Solidity, we have the formula to compute addresses. This can be used many places. Uh, what it does is it first encode peg the bytes one constant plus deployer address plus the salt. Make sure this salt has message.sender in it. So this helps you in preventing from front run attacks that we discussed right now. And then ABI encode encode peg the creation code, or the bytecode of the contract plus the constructor argument. So it uses all of them to compute the address. Uh, there are few like practical use cases of this compute address. First one is Uniswap V2 uses create2. So the routers can compute pair addresses off chain without pairing the factory contract. So the Uniswap routers uses this compute address to calculate the pool addresses like VETs, USDC address. They calculate it off chain. Create2 should be secure for immutable contracts because if an attacker tries to deploy a notified malicious code, so it's all. Yeah, if even if a single space or any line is changed in a contract, then it would completely changes. So they cannot use other bytecode to block or with the same salt. If they try to deploy it, they cannot deploy it to the same address because bytecode is taken into consideration to deploy to determine the address where the contract is going to be deployed. Yeah. So like we were discussing about the practical use cases of this compute address. Um, Safe wallet uses it so you can know your wallet address before deploying it. You can receive funds before your wallet even exists on chain. So that's very good like, use case of create2 to pre-fund your contract address before even deploying it. Also, if you have worked with account abstraction ERC4337 smart wallet accounts, they use create2 as well because uh, they are also they are not like the EOS externally owned accounts like MetaMask or something like that. They are pure contracts deployed on chain. So if they are not deployed deterministically, they will have different addresses on different chains. So to make them deploy at the same address, the ERC467 in itself uses the create to deploy the smart wallet accounts. Also, if you are like planning to deploy your contracts on multi-chain and you want easy tracking, so you can use create to deploy. Always use create2 to deploy if you are planning to deploy anything multi-chain. It helps you to manage things very easily. Okay, we'll see the code example of create to factory. We have a simple world. This is a child contract. We have already seen this. This is the same contract that we discussed earlier. We'll just discuss the vault factory. Uh, this vault factory has a mapping of address to boolean if it is deployed or if it is not deployed, right? It also emits in an vault created, and it indexes the vault address and also emits bytes 32 salt with it. Uh, Function to create vault. String call data. It passes two arguments, name and salt. Salt is required to deploy your vault to some deterministic address, external returns address, simple vault equal to new simple vault, and the thing in the curly braces is what makes the difference. The salt. This is what will trigger the create to deploy your contract instead of create of code. So this salt, if this salt doesn't have the message dot sender, it is not necessary because Message.sender is passed in the constructor argument of simple board. So this is being like considered in the init code of the uh, in the bytecode itself. So you don't necessarily have to use message.center in the sort itself if you pass message.center in the constructor argument. The second thing is once the contract is deployed, the deployed mapping marks it true and emits a vault created event along with the two parameters, vault address and sort, and returns the address. I hope it is clear. Few questions. I think this probably been answered already. But what are the chances that the domestic address already has something UI or smart contract? How is that managed? Uh, like the normal UI addresses and smart contract addresses, they are calculated using different algorithms. So EOS cannot collide with the smart contracts, but smart contracts that are already been deployed can collide, but there are like negligible chances of any collision. So like, near zero, near zero chance of any collision. Yeah, mathematically impossible. If by chance it does exist, the deployment would just revert, right? Yes, the deployment will revert. Yeah. The name in this factory code is simple parameter. It's just the name of the vault you are creating. Nothing much. Not any important argument or parameter. I hope this is clear. Uh, I think I'm moving too slow. I need to little fast to cover a lot of things. The next thing is EIP 1167 minimal proxy clones. Simple factory was also good. Create to was also like that was enhancement of the simple factory. Then why do we need minimal proxy clones or EIP 1167? The problem is deploying full bytecode every time is expensive. Suppose you are deploying a vault and that there is a 5 KB vault, and if you are deploying that 5 KB vault 1,000 times, that will become 5 MB. So deploying 5 MB of bytecode on chain can cost you a lot of gas fees. Uh, the solution is like instead of deploying the same contract every time on blockchain, deploy a teeny 45 byte proxy clone that delegate calls to one implementation. So you just deploy the one vault on chain and you can reference it, thousands of vaults can delegate call to that one implementation, and they will have their own storage, so there's no problem of any storage in the single implementation. So everyone will create their own vaults. They that will just store the data, and it will do a delegate call to the one implementation that is being on chain. So you don't have to deploy 4 KB or 5 KB of data every time on chain. You just need to deploy 45 byte proxy clone, the simple, very basic contract. cost, or it saves around 10 to 50x of gas fees. So if your factory is deploying thousands of clones on uh, thousands of contracts on chain, a same which has exactly same bytecode, so you can use EIP 1167 minimal proxy. Um, yeah. Now we will go through the code implementation of clone factory. Uh, on the bottom right, you can see the clonable vault. It is a little bit different from the actual vault, the simple vault that we discussed earlier. What is different in it, we'll discuss here. It has three storage variables: owner, string name, and boolean initialize. The initialized is very important in the this vault. Basically, this is the implementation contract that I was talking about. We will only deploy this contract once, and we'll reference this contract to all the clones that we are deploying, and they will delegate call to this vault. Okay. Uh, so it has a function initialize. You can see there's no constructor in the clonable vault because proxies don't have construct the implementation contracts doesn't have constructors because they cannot store anything. They are just simple logic contracts. So you need to have initialize function to be called to if you want to pass some pass or store some constructor arguments that you cannot because you cannot use constructor. You need to use the initialize function. So we'll pass owner and name in initialize function. Uh, but make sure that you guard this initialize function either using OpenZeppelin reinitializer or using your own variable like initialized. So this should only be initialized once at the time of deployment using only factory, or you can uh, do it manually. But make sure it is only initialized once. Otherwise, if you allow this function to be called again and again, anyone can call this function and will change the storage of this contract. Like anyone can call this initialize function with their own address, and they will take over your access control from this vault, and will you'll lose all your funds from this contract. So make sure to use this initialized variable, boolean variable, or try to use OpenZeppelin reinitializer to prevent this. This is one of the major attacks in the proxies till now. So be very careful using initialize. Make sure you block reinitialize. It has the withdraw function, which is similar to what we have discussed. Let's discuss about clone vault factory. Uh, it has implementation that this contract is deployed once only, and the address is being used here as the implementation to refer clones to this particular contract. And it has an array of vaults in the constructor. We will deploy the implementation. We'll deploy the clonable vault, and we'll store the implementation as this contract. And in the create vault, now this create vault will not deploy this contract because this is just implementation contract. It will deploy the clones. So in the very first line, you can see address vault equal to implementation.clone. So we are using the Open Zeppelin clones to directly clone this. You can just use this address and you can just um, call clone on that, and your vault will be created. And in the same, as you can see in the same function, the factory is initializing the clone as well. Like it is calling the initialize with and passing message dot sender. Whoever is creating this vault is the owner of this vault, right? So instantly they are initializing so that it cannot be initialized later, because if it is initialized later, anyone can change the address or can manipulate that. So make sure to uh, initialize it in the same function. Doubt. How do you ensure the initialize only get called once? If I using my own implementation of the initialize only get called once if I because if you see the initialized variable, uh, once it is marked true, there is no way you can mark it false and you can call the initialize again. So you can use this the same contract. You can use initialized variable, and whenever you call initialized, by default it is false. But whenever you call it will mark initialized as true, and there's no way in this contract you can make initialized false again. So when you try to rerun the initialize function, in the very first line there's a required statement if it is not initialized. So if it is initialized, this will revert it immediately in the very first line of initialize function. So this way you can prevent reinitialization. Okay. We deployed the clone of the clone and referenced it to the implementation contract, and then we initialized the initializer, and then we pushed the newly created vault to the vault area that the factory is storing, and we are returning vault. Yeah. Okay, so all right, now let's discuss when to use which factory. So it's important, like how do we decide that should I go with the simple factory, or should I go with Create 2, or should I use EIP 1167 clone? Uh, Not every time you will need Create 2. Not every time you need EIP 1167 or simple. So just start with simple. So when do we need simple factory? When you want standardized or verified deployments, and you don't if you don't care about the uh, address you are deploying the contracts beforehand. If you don't care about that, it's easy. So it's easiest and it's simple. Like just deploy the contract. You don't want to get involved in any kind of complexity of determinism. You don't need that. So you can straightforward use the simple factory. When do we need to use create to? Uh, when you want to deploy contracts deterministically, whenever you want to pre-compute the address and want to to deploy the contract at that address, you use create to. Uh, when second thing is like when you want same address across all the chains. So if you are deploying something on all the chains, like we are deploying our gardens multi-chain. So uh, we ourselves are using create to in the garden factory to deploy the gardens on the same address across chains, so that it becomes easy for us to manage gardens and transfer funds multi-chain. Yeah. Third point is to pre-fund the contract fund some ETH or something. So you can use create to. Fourth is smart wallet accounts. We have discussed that account section ERC4337 or smart wallet accounts. They use create to deploy the contract wallets on all the chains at the same address. Next is when do we need to use EIP 1167 flow? Use when spawning many instances with identical logic but different state. Like personal vault. Uh, if you are deploying personal vaults and you are deploying thousands of that, so you can use EIP 1167 clone and just deploy one main contract or implementation contract, and apart from that, just deploy the clones and delegate call to the implementation contract that already exists. So it saves a lot of gas fees for the protocol as well and for the users as well. Just that will just like one thing costly is like whenever you are calling the contract, you are doing delegate call, and every delegate call requires 2600 gas fees each time you are calling delegate call. So that to make sure that this thing balances, like if you are calling your vault very frequently, so and your vault is very basic and simple, or very small. So I think you should avoid using EIP 1167 clone, because every time you do a delegate call, that will keep on adding 2600 of gas fees. So at some point of time, uh, you'll find that the simple deployment was even cheaper instead of EIP 1167. So make sure you consider this point in mind. Yeah, a few more examples like escrow contracts. You can use EIP 1167 for escrow factory. So just they are being created once and not used frequently. They are just created to be on chain uh, for just reading purpose. Uh, Third, and when deployment gas cost is the priority, like when your contracts the contract you are deploying is too large to deploy, so and you are deploying thousands of them, it's obvious choice that you use EIP 1167 instead of create 2 or simple. Uh, Funny part is you can combine create 2 and EIP 1167 together, and you can deploy the clones deterministically on all the chains. So if you're thinking that we cannot deploy clones on other chains at the same address, you can deploy. Okay. Any doubts? Thanks. Okay, so let's continue. Uh, so now let's discuss about factory real world examples. Um, So few protocols they use factories that use factories in production. The very first example is Uniswap V2 factory. So they use this Uniswap V2 factory to deploy the pool pair contracts using Create2. Every token pair you see like VETH USDC or um, VETH WBTC has a unique deterministic address. The Uniswap router computes pair addresses off-chain using Create2. So they use Create2 for this purpose that they the router needs to create the router needs to determine the address of the pool pairs off-chain. So it makes things easy for Uniswap. Uh, same Uniswap V3 factory also uses the uh, Create2 for the same purpose. The pool pair contract is different for Uniswap V2 factory and V3 factory, but the logic to deploy them is like similar, very similar to each other. So they use the same kind of factory for V2, and they use the same kind of factory in V3 as well. Glosys use safe proxy factory to create safe proxy wallet clones. We discussed earlier that they use that to pre-fund their wallets even before deploying that. So also BLOK Capital uses factory. We right now we have two factories. The first one is Garden Factory that is being mentioned here. That we use to deploy gardens. We also use Create2 to deploy because we are deploying the multi-chain, and the other factory is Index Factory. So as you you know as we move ahead and we'll in the next track, the right orbital builder track, we will discuss about the indices and all that in detail. So at the time we will discuss about Index Factory as well. So yeah, these are few real world examples of factories. There are many more. You can search and yeah. So like we have completed the basics of factory and registry, and we have completed the entire factory stuff. The simple factory, the Create2 factory, the EIP 1167 clone factory. Now, if you have any doubt, we have a doubt session for 10 minutes, or if you don't have any doubt, we have a 10 minutes of break, so you can just chill for 10 minutes. And I think we are running late, so if you don't want break, we can just continue. If you don't have any doubts or you don't want any break, let me know in the chat. Okay, so let's continue. Okay, so now we will go deeper into the registry. We'll discuss the simple registry, a simple mapping of addresses to names or names to addresses. And it's like similar to the simple factory. Probably this is the hello world of registries. Now, second is ENS style. I don't know how many of you know ENS. It is Ethereum Name Service. So they have their own registry. Like when you try to search Vitalik.eth, the name was the name is registered with the ENS protocol. So that allows you to query the address of Vitalik using Vitalik.eth. And third one is access control registry. It uses OpenZeppelin's access control for role-based permissions, the production grade version. that is widely being used. Um, let's start with the simple registry. Uh, Go through the code. It has a mapping of bytes 32 to address, public entries. It has a array of keys stored, so you should not use the key again. It has two events registered, deregistered. It's registered with two params, uh, indexed key and indexed address. Like who is registering or deregistering the uh, entries. The first function is to register, which has two parameters, bytes 32 key and address external. Uh, requires entry key to be address 0. If it is not address 0, that means that the key is already being taken. So you cannot add the address again to the same key that is being stored previously. Second one is if address is not equal to 0. If the address you are mapping is 0, so that doesn't make any sense. This will be just like, uh, attaching the key to address 0, which is probably a spam. If this passes the two conditions, we'll store uh, entries. We'll store the entries using passing the key ID, key as ID, and address as the uh, mapping. And we'll push the key into the keys array. And make sure to emit event whenever you are registering or deregistering something. So emit the event with the key and the address you just met the entry. Uh, the another function is deregister, pass the key, and just if that exists, remove it. If you are a message.sender, the key is mapped to you. You can just deregister it. We have a simple lookup function that's very important function in the registries. If you only have register and deregister, how would you know that? How would you know what is being registered and how will you get query? So the very first use case of registries is to make queries easy and make you know registries to be like, yeah, so it makes the very easy. Okay, so let's move on to EN style registry code. Okay, from here I have two questions. I could use two different keys. Just a second. Keys derived. No, there's no way a key is derived. That was a very basic, simple registry contract. No, you cannot use. Yeah, you can use two different keys for the same address. But there's no way to, the key is derived. Okay. So let's now move on to ENS style registry. Uh, let's go through the code. Name registry, it has a struct record, which is owner, resolver. What this name points to, the resolver is the address, like the address I assign my name on ENS. And the other thing is expiry, when my domain name is going to be expired. It has one mapping, bytes 32 to record. Uh, records mapping, and a registration fees, a constant registration fee, 0.01 ether. So function, this is open to all, who anyone can call this, but you need to pay 0.01 ether, and it also has checks like, if the owner is address 0, or block.timestamp is greater than record expiring, then only you can register your name. Otherwise the name is already been taken, so you cannot call it if the name is already been taken. And if the domain name is not expired yet. The second thing it checks is the message dot value should be greater than equal to registration fee. If you are not paying the amount greater than equal to registration fee, this will revert. You will not be able to register. Once all these conditions are passed, you'll just be able to record this, and this will just save, alter the storage. So now your domain name is the name is now assigned to your resolver address, and you are the owner of it. Yeah. And consider this amount is for 1 year. Now we have a function to resolve. If the address is equal to 0, it does mean that it is not registered, so you cannot resolve anything. And if block.timestamp is less than equal to .2, if not less than equal to, it is already expired. You can transfer the ENS name to new owner using the transfer function. Okay, so we have a different type of registry, access control registry. Let's go through the access control registry code. It's like it imports the Open Zeppelin access control, and it has a registrar role. It is a role-based access control registry. So like we have service, struct address or string version, boolean active, and a mapping of string to service, public key services. And in the constructor, we grant role to the admin and registrar role to the message sender. So whoever is deploying this registry has the access of the registrar role as well as the default admin role. And to register any service, it has the only role, registrar role. So only the registrar can register any service using the registrar service. There's a simple check that it requires address should not be 0. If it is 0, then it will just return this reward with address 0. Otherwise, it will just store the service. Another function is to deprecate the service. If you don't want the service anymore, you can just call the deprecate, but only the registrar can call this function as well. And the third one is a lookup function to get service. It will return the service for the name and the version. All right, I think it is clear to everyone. Let's discuss the real-world examples of registry. ENS uses this. The ENS registry, Ethereum Name Service Registry, uses it to store resolvers like Jayesh.eth or Sheetal.eth or vitalik.eth that are being mapped to particular addresses. So to make it easier on chain to query any addresses attached to some personalities, similar to the phone book the contacts we have in our phone. So it makes it easy for anyone to just send funds to vitalik.eth instead of remembering the 20 bytes address. Chainlink uses it for Chainlink has feed registry to store price feed addresses. Uh, so whenever you try to interact with any DeFi protocol and they need any prices on chain, so they just go to feed registry of Chainlink uh, to get the price feed addresses. Uh, we at BLOK Capital use multiple registries. Two are mentioned here: the facet registry to register the diamond facets that the protocol uses, and the other one is liquidity pool registry to prevent users from interacting with the pools that don't have any liquidity. So it's the duty of BLOK Capital DAO that we must protect our users from interacting with the liquidity pools that are illiquid, or whenever you try to interact with them, you'll lose your funds. So having liquidity pool registry and a DeFi protocol is very important. In BLOK Capital, it's the most important thing. Hybrid pattern. So basically, this slide in the entire session is, most, you can consider this as the most important slide. Uh, Mostly the factories are not, you know, uh, only the factories. They are registers in themselves. So will let's suppose we have a token launchpad and it has a mapping of string to addresses or tokens. So the name like USDC is being mapped to our address that is being, the contract is being deployed, and address array of all the tokens. So now we have a function to launch the token, which takes our symbol and supply as parameters. It requires symbol uh, should be uh, should be mapped to address 0. If it is not, that means that the token already exists. The token with the symbol already exists. Now we have a factory to deploy new token. So ERC token equal to new ERC token. We pass the symbol supply and the owner of the contract as message sender. And as you can see in the function that it is the factory as well as it behaves like a factory, but it is a registry as well. So in the very next line, it registers the token that is being deployed, and it stores in the mapping as well as it will push the new token launched to all tokens array, and will return the token address. And we have a lookup function as well. As we have seen in the registry examples that having lookup function is very necessary. So you can see here that we have the lookup function as well. So keep this in mind that almost all the factories in that are in the production, they are registers in themselves. Let's discuss when to use which pattern. The first is when to use factory, when to use registry, and when to use both. So when do we use factory? When we deploy many contracts with same bytecodes. For deploying, uh, suppose for deploying walls or escrow contracts, or BLOK Capital if for deploying gardens. So at that time we use factory. Second point is where want standardized verified deployment. So let's suppose if like the garden factory is a diamond factory, right? Gardens are basically diamonds. So whenever diamonds are deployed, diamond the first diamond cut is passed as the constructor arguments, and if you allow them to be deployed without factory from individually from each user, uh, any constructor arguments can be passed in the gardens that can be malicious if they are deploying their gardens through interface, and the constructor arguments may differ and may lead to fund drains. So for standardized and verified deployment, uh, we we have chosen the garden factory, and and we derive few parameters from ourselves to be in the garden factory to be passed in the user gardens. Another important point is to deploy. If you want to deploy addresses deterministically, so you must need you must need factory to deploy addresses. If you do it manually, uh, there will be chances that you may end up deploying the addresses, the contracts to different addresses on different chains. And so for standard development, for making sure that it actually deploys to correct addresses, the exact address, you should use factory. The fourth point is when you want cheap clones, for you want thousands of the same contracts, you just deploy it once and just deploy cheap clones instead of deploying all the contracts on chain. When do we use registry? When contracts already exist but needs discovery, like price feed addresses used by Chainlink. So all that are already being deployed. They just need tracking that, yeah, these are the addresses associated with the Chainlink. Uh, Liquidity pool registry that we have in BLOK Capital, that is a very good example of registry. And the liquidity pools are already being deployed. Like we have multiple liquidity pools in the liquidity pool registry. We have pools for Uniswap V2, V3, Sushi Swap, or Balancer, or Curve Finance. So we have Camelot Finance. So all that pools are already being deployed. We just store them in the liquidity pool registry. Uh, Second point is cataloging heterogeneous contracts. So uh, heterogeneous contracts, like they don't have the same bytecode. When you try to deploy different contracts, you cannot use factory to deploy different type of contracts. So then you deploy them manually and register them instead. Just like our facet registry, it could have been a facet factory, but why it is not a facet factory? Because all the facet contracts have different bytecodes, because Uniswap V2 facet and Uniswap V3 facet and Aave facet, all they have a different init code, so they are very different from each other. So we cannot use a factory when the contracts are heterogeneous. Right? When we need versioning a proper version, so at that time we need registry to uh, store them with proper version. Uh, Fourth is need name resolutions like ENS. When do we use both patterns? When we want to deploy and want reach lookup. Uh, Usually most factories are both factories and registry. So you can consider them whenever you're trying to build a factory, to start with factory plus registry. It's very rare that you are creating a factory and you don't want a reach lookup. So just uh, the second point is when in doubt, always start with hybrid approach. So whenever I try to try to build a factory or something, I start with both the approach. Uh, when I drop the idea of factory, when I see heterogeneous contracts, if I see that the contracts are very different from each other, I drop the idea of a factory. Uh, Registry is more like used everywhere in the factories as well, and as a pure registry as well. Most factories are hybrid. Yeah, all right. Now let's move on to patents and anti-patents. Uh, let's first discuss about the patents. Uh, First thing, uh, always emit events on every create, register, or unregister whenever you are trying to perform any on-chain activity which alters the storage or which deploys anything. Always try to emit events. This is very crucial for block scanners, for your protocol to use subgraphs and query things very easily. Second, add access control to registries. It is very crucial to add access control to registries to avoid any spam activities or spam entries. Third one is always validate addresses. It should not be addresses should not be equal to address 0. So this should be considered. Um, Fourth point is always use bytes 32 instead of strings for saving gas. So whenever you are trying to store anything on chain, if you want to map something with the string, like your name with address, so always instead of your name, just make it a hash. You use Catch 256 algorithm, or you use any other uh, to convert the name into bytes 32. So it saves a lot of gas fees on chain. Just converts it into a very small value. So it becomes very easy and it saves a lot of gas. Fourth point is use EIP 1167 for gas efficiency. We have discussed this a lot of times, that whenever you are trying to deploy same type of contracts thousands of times, just instead deploy clones and map and deploy one implementation contract, delegate call from clone to implementation. Anti-patents. Unbound arrays in factories can lead to DOS, denial of service risk. Make sure uh, the lookup functions in the factory, they always they should not be like querying the unbounded arrays. You can do one thing. If they are unbounded, uh, the very first thing is that make them bounded, or if they're unbounded, make the functions, the query functions, to be queried in range like from index 0 to 100. So you can pass the start index and end index to query the data. So in that way, you can avoid the DOS, denial of service risk in unbounded arrays in factory. The second is skip initialize. Don't skip initializer guards in proxies. Most of the attacks in the proxies are due to the initializer guards. So always either have the initialized Boolean variable or use proper Open Zeppelin or initialization guards. Uh, don't allow anyone to overwrite registry entries. That this could lead to chaos. It should be proper access control. Only uh, the person the only people who are granted the role can only um, overwrite the registry entries. Don't forget to check return value of create2 whenever we try to deploy using create2. Sometimes they fail internally, and they fail silently without reverting any error. So always check the success. Check the address that they are returning. If it is address 0, so it is not been deployed. Um, Make sure you always check that. Uh, the last point is don't store any large metadata on chain. Uh, it can lead to it can lead to DOS attack or DOS risk. So make sure you emit events instead of storing more data on chain. Just keep as minimal as possible. We have a doubt. Can we just use mapping instead of array? Yeah, we can use. There are different use cases of arrays and mapping. Sometimes we need arrays. Sometimes we need mappings. Yeah, let's consider the gas cost of different operations and how much gas they require on chain. So this gas is written in way to create deploy a new contract using simple factory. It requires around 100K to 1 million of way on chain uh, because it has a byte code which is being added to the blockchain. So when you are trying to deploy something, it requires huge gas fees. When you try to uh, deploy any contract using create to factory, it requires a little bit of more gas fees because not because of deployment there is any difference in deployment. Create and create to both requires the same amount of gas fees to deploy any contract on chain. The difference comes when you calculate the address of the contract you are going to deploy and create to perform certain actions like catch echo 56 hashing of the salt and calculating the values. The difference comes there. Otherwise, the cost of deployment using create or create2 is exactly same. The third one is EIP 1167 clone. It because you are just deploying a very small 45 byte clone on chain, so it just require 40K to 55K of weight uh, and registry to register. Just it's just the storage altering on chain, so it requires 40K to 80K weight, which is very less than the actual deployments. Yeah, let's discuss some security pitfalls. Uh, Reinitialization attack. The first one is reinitialization attack. If clone is not guarded, attacker can call initialization again. So make sure you use either use initialized boolean variable or open Zeppelin's reinitialization guards. Salt grinding. Create to always use message.sender in salt to avoid front running attacks. We have discussed this in the session. Whenever you are calculating salt, always use message.sender uh, salt to avoid any type of front running attack. Third is registry pollution. Open register without validation leads to spam, and so always have access control on your registries. So mm, they should be pure and should not be polluted with spam entries. Fourth one is DOS attack. Unbounded arrays in factory can lead to possible DOS attack when the array becomes too large. So either don't use unbounded arrays or make the lookup functions make them to query in the range start index to end index. You can use this techniques to probably secure your protocol from attacks. Key takeaways from today's session: factory deploys contracts, registry indexes them. The main job of factory is to deploy contracts, whereas the main job of registry is to index them. Second, most production factories are hybrid. So as far as I have seen the factories till now, all the factories are hybrid. They they all are registries in themselves. Third, use create to for deterministic addresses. Whenever you are deploying anything multi-chain, always use create to. Uh, Use EIP 1167 clones to save gas on identical deployments. Uh, Always emit events, guard initialization, use proper access control.